Hello everybody. Am I audible? Hello. Just indicate in the chat. It is okay. Okay, please reply. I'm going to wait for a few more minutes because I only see two people who have joined. Okay, great. Thanks for replying. So let's wait for a few more minutes in case more people are joining and we can start in a few minutes. Okay. Okay, I still see only two people in the meeting. Maybe we can slowly start and people can continue to join. I'll just turn my camera on. Okay. So hello. I hope more people will join. I know this is not my usual slot, but I had to reschedule because I'm at a conference this week. So anyway, let me just share the slides. Okay, I hope my screen is visible to everybody. Yeah, okay, great. Yeah, I was saying this is not a sorry about that because I have some work tomorrow. I'm at a conference, so I'll not be able to take it. So I decided to reschedule it to today. So if any of you are joining for the first time, my name is Zenia. I am a PhD student at ISC and I work primarily in astrophysics. And as you know, and as I've mentioned before, in my work, I use Python almost every day. I would say every day for different aspects. So, this is one of the ways in which Python programming and programming in general is this very versatile subject where it has applications in almost every field that you can think about today. Okay. So the purpose of these sessions are that you have your recorded videos, which you are seeing every week from your professor, which is, related to various topics. But these sessions will actually be interacting and, solving some more problems which are related to those week material. And that can also help you in your assignments and other programming assignments and quizzes that you will be having. So yeah, as you know, the way that I like to have these sessions is that I try to give you the opportunity to try the questions yourself and program yourself, because as I said, you cannot learn programming from watching other people program or from reading books or from reading programs. You have to try to write the programs yourself. There's no other way. It's like riding a cycle where you can't read books and learn how to ride a cycle, right? You need to do it yourself. You need to make the mistakes, then only you'll be able to learn. Okay. Other bookkeeping things which I usually say is that one is that, as you know, all the slides and programs are available to you. I'm uploading them on Google Drive. And apart from that, all these videos are recorded. I mean, all these sessions are recorded and the videos are uploaded on YouTube every week. So you can, I think the links have been shared with you, but I've also made a website, I mean, a page on my website where you can find the links for easy access. So this is basically, sorry about that. This is my website. And here you can find that you have the YouTube playlist and you also have the slides of the sessions. Okay. So yeah, if you guys can want to access the materials, it's just save this link and that has everything. I'll discuss this at the end. Apart from that, yeah, if you need to ask any questions or queries, I would suggest you mail me. My mail ID is present in all the slides that I've shared with you so far. If you have, for example, want to discuss some particular topic in these live sessions, if you mail me before, say, Thursday or Wednesday, then I can include that also in that week's problem solving class. Because remember that these sessions are meant for interaction. They are live sessions so that you can interact and clear your doubts with me instead of just watching the recorded videos. Okay. So if you have any queries or doubts, you can also mail me. Sorry if I have been like a bit behind. If any of you have mailed me and you have not got a response, I would encourage you to just reply to that and send me a reminder, because I've been a little busy for this last week. I have some travel, etc. So I might have missed a mail or two. So if anyone has that issue, please let me know. Okay. So I think we can start the class. Let me see how many people have joined. Okay, you can see that only few people have joined, but it's okay. We'll start the class and others can keep joining or they can watch from the video recording on YouTube. Okay. Fine. So since there are only few of you, all of you should interact with the questions. Okay. Okay. Good. So is there a question? Sorry. Hello. Okay. If there's not a question, I'm going to mute you because otherwise there'll be an echo and it will be disturbing. Okay. Fine. So we'll start. So this is going to be about the week 4 lectures that you have discussed, and we are going to some questions and program related to the week 4 lectures. Okay. So first of all, last already said, so there were different kinds of sorting we did that. One bubble sort, then we selection sort, right? And bubble sort was, of course, the worst of them, but insertion and selection sort is also not that great. So when I say worst or not great, what do I mean? So as I said in the very first class, when we're doing programming, we have to take advantage of the fact that we are using a computer, right? Take advantage of the fact that computers can do these repetitive tasks very efficiently. So, for example, if I want to print a statement 100 times, I can write 100 print statements in Python, but that is not anywhere more different than me sitting and writing the statement 100 times by hand. There should be some advantage to me actually using the computer. So that's why you use your for loops, your while loops, etc. Right? So we have already seen that. For example, go to your very first class in the GCD program, you saw that how to calculate GCD you can do using different algorithms. So algorithms are the instructions you give to solve the program, right? So here also sorting, we saw three different ways to do sorting in the last class. One was bubble sort, where we individually identify the largest number and every time are moving it to the front of the array. Then we had the insertion and selection sort, where we are trying to, insert number in the correct, selecting the largest number in every iteration. So again, for all of these cases, we have to traverse the array multiple times, right? We have to go, traverse means I'm going from 0 to n multiple times. Like in bubble sort, I first go through the array, I keep comparing every pair of element, and then only I reach the largest element, move it to the end. So there's swapping going on at every point. Similarly, for this insertion and selection sort, I have to keep going through the array, identifying which is for insertion sort. What do I do? I keep building a smaller array, right? I keep building a sub array and building it up. So in that case, I go through, I select one element, I have to select it and then compare where exactly it has to be put. So I have to keep traversing the array multiple times. Selection sort also, I go through the array, select the biggest element, go put it at the last position, again go through the array, select the biggest element, and so on. So my point is that there is a lot of you have to traverse the array multiple times. So there has to be more efficient way to do this, right? So when does this become a problem? This becomes a problem when I have to sort, say, hundreds of elements instead of tens of elements. Then the order of complexity grows. As n means it's a very large amount of time that you're taking. Again, there has to be an advantage to me using the computer. I can't just use something where it's going to take a long time. Means I would rather not do that. So that's why the merge sort and quick sort have come. So these two are sorting algorithms which are based on what is called this divide and conquer method, where you're taking the array and you're going to divide it into sub arrays, and then you're going to deal with those subarrays and then put them back to. Even in merge sort and quick sort is a little better than the merge sort. Now, to understand both of these sorting algorithms, we need to understand something that we had already discussed last week, which is recursion. So can anyone tell me what is recursion? You can put it in the chat or you can unmute. Any of you, what is recursion? We discussed it last week, right? So recursion.
Ma'am, we cannot see your screen, ma'am.
Uh, yeah, yeah. So I was asking what is recursion. Can you see my screen now?
Using a function inside the function.
Yeah, exactly. Thanks. So basically, what you're doing is recursion is when I'm, as someone said, calling the function within the function. I think that's what you said. But more importantly, yeah, exactly. So what we are doing is we are defining the function using itself. Right? That's called recursion. So what you will see is that in both these sorting algorithms, merge sort and quick sort, we are going to be using recursion. So remember that our goal is to sort the elements. I'm going to try to do the element sorting in a way that's based on divide and conquer, where I'm dividing the array into subarrays and dealing with subarrays, so that every time I don't have to go through all the elements of the array, I can deal with some smaller arrays and do that. Apart from that, I'm also going to be using recursion. So these are the main points to keep in mind. Apart from that, you also saw about tuples and dictionaries that I'll talk about later. But let's first look at these sorting algorithms that have been discussed. Okay, so before I start, I've been showing this slide in every one of my presentations because this is important. You are starting out coding in Python, and or some of you are starting out coding. It's very good to have some certain good coding practices. So always try to choose some meaningful variable names, function names. Don't just keyboard smash, even though it doesn't matter. These kinds of things make your code you can write a program, but to write a good program, try to keep these things in mind. So, choose meaningful variable names, file names, function names. Don't just keyboard smash, like have something written that is relevant to the problem. Use comments extensively, and white space, which means the spacing between the letters and all, you use that properly so that your code looks neat. In Python, it's very important to use indentation properly, because otherwise your code itself won't run. But generally, it's good to have enough spacing between, say, a loop and what is inside the loop, so you can identify what's really happening. And the README files part is when you start to develop your own codes. It's always good to have a document or a README file which tells you exactly what that code is doing. So these are the things that will help you to actually write good programs, where you can just give the program to someone and they'll be able to understand it. The goal is to write such a program that once you give the program to someone, they don't have to come back and ask you many questions. Okay. And it doesn't only help other people, it can also help yourself, because what you will find is that sometimes you write a program and then 6 months later or 1 year later, you go back and try to see that program and you don't remember what it does, or how it's doing it, right? So if you have proper comments and variable names, this will help you a lot. Your future self will thank you. Okay. So let's go back to sorting. As my screen says, oh, sorry, one second. Yeah. So let's talk about merge sort. Okay. So merge sort, as the name suggests, is where we are going to merge two arrays together to get the sorted array. Okay. Not two arrays, like sub arrays. Okay. As I said, these two algorithms we are discussing today are based on divide and conquer. So we need to first divide the array. Okay. So here you can see that we have divided this array. So in the example given on the screen, you have these four elements in the array: 38, 27, 43, and 10. Okay. Now 38 and 27, we are dividing the array in the middle. So 38 and 27 are their own array, 43 and 10 are their own array. Now 38, 27, we are further dividing in the middle. 38 is one array, 27 is one array. Array or list can have only one element also. 43 is one array, 10 is one array. So now if we have only one element in a list, that is by default sorted, right? It is already sorted, because there is nothing like sorting one element. It is by default sorted. So now what I do is I take sorted subarray and I want to put them back together. Okay, so that's what's happening here. I say that 38, the element, this array containing 38 already sorted, 27 already sorted. So let's call them 1, 2, 3, 4. So there's four arrays. I say that all four of them are already sorted. I want to combine these two arrays back to one array now. So 38 and 27, when I combine in such a way that 27 comes first, then 38. So I'm sorting these two elements first, these two arrays into a sorted array. Similarly for the other case. Okay. Now what I'm doing is, now I have two sorted arrays, right? From four sorted arrays, I'm calling it sorted array, even though it's just one element, because as I said, by default, one element array are sorted. Okay. Now those one element arrays I have made into two element sorted arrays. Now both the two element sorted array I want to make back into the four element original array with the sorting. So you can see that I don't just merge it, like put them together. So when I say merging is not just writing 27, 38, 10, 43. I actually merge in such a way that the array position is correct. Okay, so you can see that 10, then 27, then 38, then 43. So what is recursive about this process is that to sort the four element array, I have to first sort the two element array, and then I have to sort the one element array. So merge sort of 4 calls first the merge sort of the two element array, calls the merge sort of the one element array, and so on. So that is why there is a recursive nature to this problem. And when we are merging, we have to take care of the order of the elements, because that's only where the sorting comes in, right? The sorting comes in when we are merging back the elements. So this gives some advantage over the normal sorting, but not so much. To get even better advantage, because we have to finally merge the array back together. For that, you do need to traverse through the whole array, identify the correct location, and so on. So still, if you have 100 elements, say, this will still take some time, because if you have 100 elements, you have to break it down into 50, 50, then 25, 25, and so on. And then what you'll do is you'll be looking through the array when you're trying to merge it back together also. So it will still take some time. So even more efficient algorithm is called quicksort. Okay. So in quicksort, what you do is, instead of merging the arrays, or instead of you also try to subdivide the array into smaller arrays, but instead of breaking it down and then merging it, you choose a pivot. A pivot is a number or a position in the array, and what you do is you take all the numbers before the pivot, I mean smaller than the pivot, and place it before the pivot in the array. Take all the numbers larger than the pivot and place it after the element in the array. So you can see, for example, this array initially might have had some other configuration. Since 5 was chosen as the pivot, all the elements higher than 5, 6, 7, 9, and 10, they are placed after 5. All the elements which have a value less than 5, 4, 3, 1, and 2 are placed below 5. Notice that it's just placed randomly, right? It's not like I have not sorted and placed it. I've just placed it 9, 7, 10, 6. Now I have to further I'll have to further arrange this, right? So now in 9, 7, 10, 6, if I choose 6 as the pivot, then you can see that all the numbers are larger. So I'm placing everything after this. There's no number before it. Here 2 is chosen as the pivot, and you can see that. So again, you can see this recursive nature, right? First we choose a pivot and we do the entire process of keeping all the bigger elements after it, smaller elements before it. Then from the right array, which has the bigger elements, I choose another pivot, do the same process. Again, I choose another pivot, do the same process until I get only one element. And as I said, one element is by default sorted. Okay, so until I get one element, I keep repeating this process. So that's what I mean by recursion here, because we have to keep subdividing and repeating the process. Now, I'll just show you how the programs look in this case. So I have two programs. Before that, sorry, is there a question? Okay. Okay, I can see that. Okay, fine. So before I go to the programs, does anyone have any questions in this sorting? I think if you have questions also, if you look at the programs, it becomes a little clearer. Okay, so the idea is that we are trying to find out sort a better algorithm for sorting rather than and other things. And for that, we are going to be using recursive methods, two recursive methods. One is merge sort and one is quick sort. So let's first look at merge sort. Okay, so I'm going to show the program. I hope you guys can see. Okay, can you guys see my screen? Is the program visible? Okay, I hope it is visible. If any issue, please let me know. Okay, so you can see that I have two functions which are defined for the merge sort, right? This is just for printing the array. One is a function which actually does the merge sort. It calls the function merge sort. And this is where the sorting happens. The other function is for merging the array. So remember, in merge sort, what we're actually doing is we divide the array, we keep dividing the array, and then we merge it together in the correct order. So right, you have to divide the array into two parts and then divide that array into two parts. That's why it's recursive. So it keeps dividing. Then we are sorting those smaller arrays by merging them in the correct order, right? So as I said, when you have only one element in an array, it's by default sorted. So when I'm trying to merge two one element arrays, I have to merge them in. Okay. Oh, okay. Someone is saying that the screen is not visible. Is the screen not visible? Okay, okay, okay. Give me a second. Let me just stop sharing and I'll reshare. Is it visible now? Can anyone confirm if the screen was visible now? Okay, no, yes. Is it visible now? No, okay. Okay, give me a second then. I'll just leave the meeting and join back. Hello, can you hear me? Am I audible? Okay, I'll leave the meeting and come back. I'm sorry, I'm not in my institute right now. So maybe some internet issue is there. Let me just leave and come back. Okay, I'll just do that. Hello, am I audible? Am I audible? I'll turn off my camera. Maybe that will help. Am I audible, everyone? Okay, good. I'll share my screen. I'll keep my camera off. Maybe that is too much, like taking too much bandwidth. Can you see my screen now? It's visible, right? Okay, great, fine. Was it not visible for during when I was displaying the slides? Okay, that's fine. I now you can see the program. That's the important part. Okay. So I'm now talking about merge sort. Okay, so merge sort, just in case my screen was not visible before, I'm just showing this again. This is a, like, just if you look at this graphic, you can understand what is merge sort. You have an array. I keep dividing it into smaller arrays. Okay, so half. I divide the array by half into two half subarrays. I keep dividing it until, and then you merge the sorted halves back together. So you can see that you keep dividing. This four element array has become two element array, that has become four one element array. Whenever you have a one element array, it is by default sorted. That's what I was trying to say. So then you have to merge it back, and this merging back you have to do in a very subtle way so that the sorting is maintained. Like here, when I merge 43 and 10, I have to do it in this order, that 10 comes first, then 43, and that's how the sorting happens. And then when I merge these two elements, these two subarrays together, I have to again take care of the merging within the array also. So this is merge sort. So let's look at how it looks like in the program. Okay. So when I take the Python program, you can see that I have two functions here. I have one function called merge. I have another function called merge sort. Okay, so merge sort is actually a recursive function. You can see that in the definition of merge sort, I've called merge sort itself. So that's what I mean by recursive function. As one of you correctly said, a recursive function is when we call a function within a itself, right? Okay. So let's try to understand what's happening in the program. So merge sort is where the actual merging is happening. You can see that I identify what is the middle element, right? Left plus right by 2. And I do this double slash. Anyone knows what double slash means here? Left plus right double slash 2. Integer division, yes, very good. So integer division means that I am not taking any floating point value or anything, because here I just want to identify the middle element, right? If it's an even number of elements, so suppose it's 6 by 6 plus 0 by 2 or something like that. So that is the thing. Okay, so actually 6 elements means it will be 0, 1, 2, 3, 4, 5. So it will be 0 plus 5 by 2. It will be the third element, like that. Okay, second element, which is third because the indexing starts from 0. So just remember that index starts from 0 always. So this is just to find the middle element. Now you can see that I call merge sort first of array of left of plus comma middle, and merge sort of array of mid plus 1 and right. So what is this exactly doing? What I'm exactly doing here is I am separately, first I'm identifying the middle position, and then in that middle position, I'm separately calling merge sort on the left half, and this is for the right half. So these two is, this is basically for the left half, and this is for the right half of the array. Okay, and why and as I said, this left half right half business keeps repeating. Why does this keep repeating? If you notice in the function, I have a condition. If left is less than right, I should keep continuing it, right? That means that every time it will keep dividing it and doing this whole process, and the moment this becomes false, that's when we have just one element in the array, because in that case left is equal to right, right? That is the both of the indices are the same. So at that point it will. So this loop will keep running, and it will keep running merge sort on, it will keep dividing the array and then doing it. So then after that, it will be merging at the end. So this is the idea of this loop. We are identifying the left half and the right half of the array. I'm putting it in a loop. Within the function, I'm calling the function means it's recursive. That means I'm calling, that means that I keep on repeating the process until I reach this particular case. Okay. So here, what will be the base case of our recursion is basically when I reach the one element array, because as I said, one element array is by default sorted because there's only one element. There's no meaning of sorting here. Okay. So now let's look at how are we merging the array back together, because that's actually where the sorting is happening, right? The sorting in this case is actually happening when I take the two halves and put them back together, because when I put it back together, I put it in such a way that you have to maintain the sorted capacity. So let's see how we are doing that. Okay. So here you can see that merge is this function which takes an array, the left index, right index, and the middle index from it. Okay. One sec, sorry. Just checking the chat. Okay. Sorry, one sec. Yeah. So array, left index, middle index, right index. Now you can see that N1 is mid minus left plus 1 and N2 is right minus mid. So this is the last, this is the length of each of these arrays. That's what this is telling us. This is the length of how long these arrays are. We are creating some temporary arrays called L and R, which are initialized to have this much length, N1 and N2, which is the length of the left and right arrays. So now you're copying the data to this temporary array left and right. Why are we copying to temporary arrays? Because we'll be sorting the actual array. So we need the actual information to be stored somewhere, right? So now you can see that this is the initial index of the first subarray, so the left half as I'm calling it. J is the initial array index of the second subarray, and K is the initial index of the merged subarray. So I'm trying to create a merged subarray now, starting with the leftmost position. Okay, so the leftmost array is first position. That is what is happening. So now you can see that we are merging the temporary arrays back into this position, and you can see that while I is less than n1 and j is less than n2, we compare them. We compare the left array and right array elements, and then we put them in such an iteration. So you can see that whichever is smaller, we place it at the kth position, and k is left. Left is basically the first position, right? Left is, I mean, it doesn't have to be the first position, but basically, if you have left array and right array, this is left, mid, this is mid plus one, and this is right. Okay, so that is how the indexing is working in this case. So we start with the leftmost position, then we compare whether L of I is less than R of J. Why do we have to compare between arrays? Because if you look at this example, for example, we have 27, 38, 10, 43. I can't just merge them like that. I have to first compare 10 and 27. I find that 10 is smaller, so I place 10. Then I compare 10 and 27 and 43. Then I see 27 is smaller, so I place 27. So that's what I'm doing here. So that's exactly what is happening here. You can see that L of I is less than equal to R of J. I check. Based on that, I place something in a particular position. If, for example, there are any remaining elements which have not been checked, those are all placed after this in L of I. Then you copy all the remaining elements of R. Then finally, that is it. The merging is done. So let's try it out with this case. You can see 12, 11, 13, 5, 6, 7. If I now run the thing, you can see that the sorting is done. So what has happened in this case? It has divided into two arrays, 12, 11, 13, 5, 6, 7. Then the two arrays, again, it's divided 12 and 11 and 13 and 5, 6 and 7, something like that. Then when it merges back, it checks for each of them. So like 12 and 11 is further divided into 12, 11, and then 13, 5, 6, 7. They're all made into one element arrays. Then 2, 2, 2, they are combined back. Then they are sorted. Okay. Is there a question? Okay, if there's not a question, I'm going to mute you. There's some feedback coming from the mic. Okay, I'm just muting. Okay. So yeah, so the way to think about this is I am basically dividing the array. I keep on dividing the array into half until I get only one element. Okay, and that one element is considered to be sorted. And then when I merge it back, I have to take care that these conditions are satisfied. So this loop is basically what is doing the merging. Okay. So this is the idea behind merge sort. I hope, is there any doubts? Is this clear to everybody?
Yes, ma'am.
Okay, good. Thanks. Thanks for the reply. So now let's go to quick sort now. Okay, so quick sort is the other case which I spoke about. So again, I was saying that both of these are based on divide and conquer. So in merge sort, this complication does arise that you have to merge the elements back together, right? So you do have to traverse the array. Here instead, you're just, here also you have to traverse the array because finally you do need to compare in order to sort an array. But our goal is to minimize the number of times we compare, right? That is the idea. So here what we're doing is we actually choose a pivot as is shown here. as I showed in the previous thing. Choose a pivot. We move all the elements which are larger than that number to one side, all the elements are smaller to than that number to another side. Then we keep doing this. We take the second half, do that process there, the other half do that process there until you get again one element. So again, these are recursive processes. So we keep repeating the process until we just get one element arrays. One element arrays are sorted. Remember, in recursion, you always need a base case. If you don't have a base case, what will happen is you will go for an infinite loop, right? For example, when we did factorial program, or I don't know, I told you guys to check out the factorial program. If we didn't give that 0 factorial is 1 or 1 factorial is 1, we'll keep on going to smaller and smaller factorial, just keep on going infinitely, right? That's not going to help us. So we need a stopping case. In both of these cases, the stopping case is when the array has only one element, because one element is sorted by default. This is the idea. So let's look at the program of quicksort now. As you can see, okay. So again, we have two parts. Actually, we have three parts. There's one more function for swapping, but swapping we have already discussed, I think, two classes back. We discussed various ways to do swapping. You can go and check the programs if you have any doubts. So using a temporary variable, without using temporary variable, etc. So swapping you should be familiar with. So there is a quicksort function here. So similar to before in the merge sort, this is actually the recursive function which is calling quicksort over and over again and partitioning the array into subarrays and subarrays. So what is the difference between quicksort and merge sort is what you do with those subarrays, right? In merge sort, I keep partitioning the subarray and then I merge them back together in a particular location. Whereas in quicksort, I'm actually dividing into subarrays and then I'm identifying a special element every time and then just sorting around that element. So that's why it's called a pivot. A pivot is something that is like a, it's like the handle, right? It's like a handle of something. So that's what I'm doing here. I'm considering the pivot to be that element. I'm putting all the elements higher in one side, smaller in one side, and I'm pivoting around. That's the idea. Okay, so let's look at what is partition actually doing, because quicksort is just the algorithm that applies quicksort to it over and over again. So this is the recursive function, but the actual sorting or the actual idea happens in the partition function, which I have called here partition, right? So let's go here. So partition again takes an array, it takes a low point and takes a high point. So here the array, you can choose any pivot, by the way. In if you can try this yourself. By the way, as I said last class also, all the sorting element algorithms I am discussing to you today, they are all based on ascending order sorting, right? They are all arranging an array from smallest element to largest element. I highly encourage that all of you try to rewrite these programs for doing the opposite, arranging an array from the biggest element to the smallest element. It is very trivial once you understand the smallest to biggest. Few changes you have to do and you will get the algorithm. But there are two things. One is that if you try to rewrite the program on your own, it will actually give you an idea about if you understand the algorithm or not. Instead of just reading the program, you can try writing it again. The other thing is that you're writing for a slightly different case. So you also have to figure out the algorithm again in that sense. Okay. As I said, it's a few small changes, but still figuring out those changes yourself will help you to understand the algorithms better. So that goes for today's algorithms also. Both the quicksort and merge sort algorithm I have shown you is for arranging arrays from smallest to biggest. I encourage you guys to do it also the other way around. Try to write the same algorithm for biggest to smallest. Okay. Identify the points where the changes have to be made and don't just change only those points. Try to sit down and write the program from scratch. That will help you. Okay. So as I was saying, in quicksort we have a pivot and then we arrange the elements all bigger than the pivot on one side, smaller than the pivot on the other side. So here we are taking the pivot to be whatever is the high element array. So in the first pass it might be low and high, maybe yeah, you can see that in the first pass, we just take low and high to be that. After that, we just take whatever is up to the partition point. So in the first case, we take the whole array and then we may choose this as the pivot. Then we'll just take whatever is about that, like we partition and then we consider we have to now put all the elements which are bigger than 6 on one side, smaller than 6 on the other side. Then we take these two arrays. So this will be low and high and this will be low and high, then this will be low, high, etc. etc. So we have to keep continuing this process. This is why it's recursive. So now you're going to the partition, whatever it is. So here you can see that we choose a pivot and you take the index of the smaller element which indicates the right position of the pivot found so far. Okay, so this is basically low minus 1 tells you you're starting at the very start of the array, or whatever is just before the pivot. You can think of it as either way. Okay, so basically you're starting at the very first element of the array. That's what low minus 1 means. So in the very first pass, low is 0, so you're starting from I is equal to minus 1. Okay, and you can see that I increases every time you find an element which is smaller than the pivot. So basically this low controls how many elements are there before the pivot, and it keeps increasing. So the final value of low will tell you exactly how many elements exist before the pivot. So every time there is an element which is found before the pivot, for example 6, every time I find an element which is smaller than 6, I increases, and I swap I and j, so that I is at the so that that small element is at the first position, right? So I keep doing this, and I at the end tells me, the value of I tells me how many swaps happened. That means that how many elements are actually smaller than my pivot. So you can see that pivot is moved after the smaller elements and return its position. So this is basically the swapping for the pivot. So once I do that, automatically all the high value elements are at the right side. No, I have placed all the low elements on the left side. So this is what happens. And because this is recursive, as I said, you first do this for one case, then you keep calling it over and over again until you're left only with one element arrays. So this is the idea behind quicksort. Is this clear to everybody? I know it's a little confusing, okay, because recursion itself is a little confusing. We keep calling the same function and over again and so on. But yeah, if you have any doubts, you can tell me. Okay. Is there a doubt? Is it clear? Okay. I think you have answered that it's clear. But yeah, I would say that if any of this, you can take some time to understand, it's fine. It's totally fine. Not only this, the other sorting algorithms also. So you saw that there are now 5 programs to do the same thing, right? We are doing the same thing, which is sorting array from ascending to descending. So one thing you can do to understand these programs better is, as I said, you can try to do the opposite, which is descending order. Sorry. I said ascending to descending. That's wrong. I meant smallest to biggest. One thing you can try to do is try to do the opposite, biggest to smallest, with all the 5 algorithms, and try to write it yourself based on what you understand from the logic. That will help you a lot. The other thing is, if you are stuck somewhere, try to print lines. So as I said, whenever I don't understand a program, I just print the value of I or print the value of j. That tells me a little better about what's happening. Okay, so these are the 2 tips I have. Just give me 2 minutes, I'll come back, and then we can discuss the rest of the thing. Okay, sorry about that. I just had to change one thing. Okay, fine. So let's go on to the next part. So apart from sorting, you saw 2 new data types in Python. One was tuples and the others were dictionaries. So as we have discussed already, the name of this course is Programming Data Structures and Algorithms in Python. Data structures are basically how you store and manipulate your data. We already have seen one very good example, which is lists, and lists are basically arrays. We can change them around, we can add onto lists, we can remove elements from lists. They are very flexible, right? Tuples are similar to lists, where tuples are ordered collection of elements with the same name, similar to lists, but you can see that they are written with rounded brackets instead of square bracket, and they are unchangeable. So once you define a tuple, you cannot change its elements like that. Okay, so let's try to see this in action. I'll just share my terminal. Let's go to Python 3. If I define a tuple as say 1, 2, 3, 4, and then I try to do this, so a of 0 is 1 and a of 3 is 4. If I now try to do this, a of 3 to be 5 instead, it doesn't allow me because tuples don't cannot be changed once they are defined. Tuples are unchangeable or unmutable. So the same thing if I do with a list, and I do a of 0 is 1, a of 3 is 4. If I do a of 3 equals 5, you can say that it works perfectly fine. And in fact, now if I write what is a of 3, it gives me 5. If I ask what is a, it gives me 1, 2, 3, 5. So this shows you that tuples are different from lists in this way. So suppose you have, each of them have their own use. Suppose you have some data or something in your program that you don't want to be changed, then it's a good idea to use tuples because accidentally also you won't change it, right? Even if you try to change it, the program will throw an error. So this is the idea behind tuples. Next is about dictionaries. So dictionaries store data in key value pairs. Okay. So pairs means uh, there are yeah, it stores them as two at a time. So it's, you can see, for example, this dictionary has a name John, age 36, country Norway. So name and John are stored together, age and 36 are stored together, country and Norway are stored together. Here name is the key and John is the value. Age is the key, 36 is the value. Country is the key, Norway is the value. Okay, so they don't allow duplicates, which means that I can't have name John, age 36, country Norway, then again use country India. That won't be allowed. Every key should be unique. Okay, that's what it means. Okay, so this is about tuples and dictionaries. I think you guys know about this stuff. So now let's go to the main part, which is like solving some questions and doing some programs. Okay, so as usual, I'll share this question. I'll give you a few minutes to answer. Today, there's only like 3 people in the chat, so I expect all of you to answer because then otherwise it's going to be difficult for me to conduct the class. Okay, so please all of you answer in the chat what your answer is. So let's start. So this is the first question. What happens if you try to add a new key value pair to a dictionary using a key that already exists in the dictionary? So these are the options A, B, C, and D. You please answer with A, B, C, or D in the chat. Okay, I see two answers, A and D. What about anyone else? There was one more person in the meeting. What's your answer? Okay, maybe we can go to the answer. So the answer is actually A. So remember, there's a difference between overwriting and appending. Okay, appending means that the same for example, using the same example before, country was the key and Norway was the value, right? Appending means that if I had country and India, then it would just show that country Norway India. That is not possible. possible. It will overwrite the existing value. So if I define a dictionary saying that blah, name blah, age blah, country Norway, and then I run something to change the value of the key to India, then that will be changed. It won't be appended. Okay, so you can just try this out in Python yourself and see what happens. Okay, so let's go to the next question. Consider the following Python function. Okay, it's called some mystery of L, and L is, if L is equal to this, etc. So the question is, what is the mystery of this list return? I'm just seeing. Please answer. Put your answer in the chat when you figure it out. Any answers from anyone in the chat? Okay, that's fine. We'll go to the answers. So the answer is actually that the list is printed in reverse. So can anyone guess why that is? No, the sum won't come, right? Because here you can see that this is again what is this is the, this is actually what is called, this is again a recursive function, right? Because I am returning, I'm calling mystery, and then in mystery, I'm again calling mystery within it, right? So what I'm doing is when I'm running mystery, I'm running it from the first element to the end, and then the last element to the end as well. And then I'm removing each element. So that's why first means it will be actually the second element, right? Because this is zero. So it will be 14, 90, 14, and then up to the first. So, instead of 14, 20, 22 and 14, it'll be 14 and 22. That's what happens. So it's basically reversing the.
Hello, friends.
Yeah, it's not sum, it's sum of different. It's not even sum of different index. It's like I'm taking two lists. Okay, I'm going to mute this person. I think there's no question. Yeah. So basically, I'm taking from the first element onwards, then I'm taking up to the first element. So now what happens is 22 comes at the end, right? Because this will be 14, 19, 65, 82, 55, then 22 at the end. Now in the next iteration, 14 will go to the end. In the next iteration, 19 will go to the end. So it's reversing. Got it? So do you understand what I'm saying? So basically, every time I am taking the first, if I write this L up to 1, that means only the zeroth element. Every time the zeroth element is placed at the end. Then in 14, zeroth element is placed at the end, and so on and so on. And it's recursive, so this keeps happening. Okay, so this is the idea. Okay, I think it's clear to everyone. This is basically, as someone said, is reversing using the slicing operations. Okay, okay, good. Let's go to the next question. I see that there are more people in the chat, so please answer the questions also. So this is one. What is the value of pairs after the following assignment. So this is one statement which is assigning pairs to have some value. Pairs is equal to x comma y for x in the range blah and for y in the range blah if x plus y something. So what does this return? Or what value does pairs take after I run this command in Python? So I'll give you a minute. Please answer in the chat, those of you who are here.
In terms of value of x and y, where x plus y
Hello?
modulus 3 is equal to 0. Like it returns the value of x and y, where x plus y modulus 3 is equal to 0.
Yes.
If the sum
Yeah,
of
yeah,
x and
yeah.
y divides completely
Yes,
with 3,
exactly. Okay, good. Good. Yeah. So that is the answer. I think he has given the answer. So it will choose x and y such that the sum should be divisible by 3. This is what you are saying, right? Hello?
yes ma'am, yes ma'am.
Yes,
The
exactly.
sum
So
of
here
x
you
and y
can
is
see that
divisible by 3. The sum of x and y.
exactly. So you can see that this is the answer that I think this aligns with what he's saying. So you can see that x, so x has some range. Here x's range is 4 comma 1 comma minus 1. And we had discussed this minus 1 business few classes ago. Basically, what will x take? It will take the values 4, 3 and 2. It will not take 1 because remember in range, the second value is not considered. Okay, it's only up to the just before the second value. Similarly, 5 comma 1 comma minus 1 will take the value 5, 4, 3 and 2. Now you have to take 4, 3, 2 and 5, 4, 3, 2. You have to take those combinations which give I plus j to be divisible by 3. Okay, so here there are two concepts to keep in mind. One is this concept of range, where the second value is not considered. Like when I write range of 5, that means 0, 1, 2, 3, 4. It does not consider 5. Similarly, the other concept is you can see that I was at a shot able to assign x comma y to a variable by keeping a for loop and an if condition in a single line. So this is kind of like a very unique thing to Python, or I would say one of the advantages of Python is you can write code like this, where you can just assign a variable and put a for loop and an if condition, two for loops actually, all in the same line. You didn't have to write for x is in this range for you can also write like this. You can also write like that. That's perfectly all right. But this just shows you that in a single line you are able to do x, y, and the condition also. Okay, so this is the advantage of using Python, but there's also a danger. As I said before, when code becomes very simple, it also becomes very simple to make mistakes. So always be very careful about what you're doing. Okay. So this is the next question I'll go to. This is the next question. So this is
In the no,
probably
excuse me. In the previous question, the pairs is a
yes.
variable, is it? The pairs
Yeah, yeah, it's a variable which stores these values.
in the place of x, the first for, the place of y, the second for, is it?
Yeah, so basically pairs is a variable where each element is x comma y. It's a tuple. Okay. Now, uh, the how are x and y chosen is that x and y are chosen from each of these ranges. X is in the range 4 comma 1 comma minus 1, y is in the range 5 comma 1 comma minus 1. But then an additional condition is placed. It is not just x and for all the x and y in these ranges, it's only for those in x and y in this range which satisfy this condition of x plus y mod 3 equals 0, which means it's divisible by 3.
So,
Does it make sense?
yeah, yes.
Okay.
Thanks.
Excuse me,
Okay.
excuse me.
Okay, good.
Ma'am, excuse me.
Yes.
Then is it like the loop is for loop? The for loop x in range is 4, 1 and minus 1. And inside the for loop of x, and the second loop is another within this loop for y in range. Is it like this? There are two for loops.
Uh,
One is
yeah, there are two.
one is
Okay,
inside the
I
other.
understood your question. You're asking if for x in this range and for y. Yeah, you can think of it like that. Because for every x, you have a y in that range, right?
It, we can use that interchangeably. First for y
You
we
can
can
use,
use it.
yeah, yes, you can use it interchangeably as well. I think it will give the same answer because here you're just the order. I mean, finally you're giving it as x comma y. So finally it will identify the correct element. So that is not a problem. You'll get the same values only.
Okay, okay, fine.
Okay, so this x and y for loops you can do in any order. It's basically to identify which are the values of x and y which is satisfying. That's all.
Oh, okay.
Okay,
Is
great.
it
Let's go to the
nest,
next. Sorry,
nested
yeah,
loop?
yeah. Sorry, please go.
Is it nested
Uh,
loop? It is
it's kind of like, so here it's like all written in one line. So I don't know if it's correct to call it a nested loop. You can think of it like a nested loop and you can certainly write it as a nested loop. But I don't know if that terminology is correct here. That's why.
okay.
Okay, great. So any more questions or shall I go to the next one? I don't think any more questions. We can go to the next question. It is the next question. This is a dictionary. So we just discussed dictionaries, key value pairs. And here you can see that it's called wickets and there are some keys and values given. So which of the following statements does not generate an error? Okay. So which of the statements basically is a correct statement? Okay. Three of these statements are going to generate errors. So please put your answers in the chat.
this case, we are assigning some values to the ODI Ashwin. We are newly adding the
Hmm.
value to the wickets. But here we are using a square bracket, right? But we are having the dictionary, right? What is the
Yeah, but dictionary, I think you can with square bracket. We'll check it after the thing. So once you answer, we'll check. You're saying
yes?
dictionary cannot be accessed by, I'm not sure actually, I don't remember. We'll check.
And I think C is correct.
Okay, so C is correct. Someone says D.
We are, we are giving value of Ashwin value for Ashwin for the ODI, that is 4.
Okay. Okay, so I saw that two people are saying D, one person says C. Okay. I can see majority saying D, one person saying C. Let's go to the answer maybe, or yeah, I think we can go to the answer. The answer is actually C. Okay. So here what is happening is that, as I said before, you can't have a duplicate key. Okay. And you can reassign the value to a key, but you can't have a duplicate key. That's one thing. And also, if you directly try to assign something to a new key which does not exist already, that can give an error. Okay, so this is the idea. So here, this is okay because ODI already has this Ashwin. So wait, sorry. No, ODI and Ashwin, there is no key already existing. So we are trying to like kind of make a new key completely, and that's why it's okay. But here in the all the other cases, I'm trying to bring in something which doesn't exist, right? This ODI, there is no Ashwin already there. So I'm trying to just extend or make something which doesn't exist basically. That's why C is the one which does not generate an error. So the question is which is the correct statement. So C is the correct statement. Now let's see if the indexing works with the square brackets or if I have made some mistake. Let's see. So okay, wait. So let's do this in a slightly simple way. Let me clear first. Exit, clear, Python 3. Let's put it as A is equal to some BC, DE, right? Okay, what is the issue? Oh, no, I have to give A dot dict, right? I forgot. So it's like, mm, wait, 1 second. I forgot how you define diction. This does not work. Okay, fine. This works. So now, if I give this statement, it should not give an error. So it didn't give an error. Okay, so this is fine. So you can access with square brackets only. Let's try one of the other statements. Okay, it seems to work. Oh, because I already created Ashwin in ODI, so that's why it didn't give an error. Let's try it again from the beginning. Okay, if I now run this, this should give an error. Yeah. So that's the point, right? There is no key such as Ashwin, so I cannot change it suddenly. Yeah, I first have to create that key with some value, and then I can do all these manipulations on it. So that's why that raised an error. Is this clear to everybody? Basically, I was trying to, do actions on a key which did not exist. That's why those other cases will give error. In C, I am newly creating a key and assigning it a value. Okay, so that is the idea. Great. So let's go to the next question. Assume that hundreds has been initialized as an empty dictionary. Which of the following generates an error? So here you have to find the wrong statement. Before you are finding the correct statement, here you are finding the wrong statement. Okay. Okay. Someone says A. Other answers? Okay. One person says B. Others? Okay. Again. Okay. Confused between A and B. I think, yeah, the answers seem to be A and B. Both are people are between A and B also. But let's see. Okay, I think I'll go to the answer. I think the answer is going to be slightly surprising to you guys because the answer is actually D. So the answer, the reason why it's D is because dictionary key must be immutable values. Can anyone tell me what that means in terms of this answer?
Because ma'am, keys are written in list form and list is immutable.
Exactly. What does mutable mean here? Mutable means that it can be changed. List can always be changed, right? But key should never be changed. So that's why these two are fundamentally wrong. The C option, it's a tuple. That's fine. The B, we are just giving it a value. We are giving it a name as a string. That's fine. A also, it's a string. That's fine. But D, we are actually assigning it to a list. List can be changed at any time. So that should not be allowed. So let's try to do this because that will help us to understand better again. So let me again just exit and clear my screen. So if I go to Python now and let me just run this hundreds to be an empty list. And let's run all of them one by one and see what kind of error they give. So first one, it's fine, it runs. So now if I give hundreds, what happens? You can see that I have Tendulkar comma international to be the key and 100 to be the value. So let me now again make this into an empty list. Sorry, not list, dictionary. Let me make this into empty dictionary and run this again. Oh, sorry, I ran it with a space. That's why. Let me just. Sorry about that. That's not an error. That's because I had kept a space by mistake. Okay, so you can see again now if I do hundreds, you can see again Tendulkar is the key. Here the value is another dictionary. So in that dictionary, international is a key, 100 is a value. Now again, I'm going to run the third statement. So let me go back and make it an empty dictionary again. If I just run this, now if I print the dictionary, you can see that Tendulkar, comma, international is the key and it's a tuple. Why is tuple allowed? Because as I discussed before, tuple is actually immutable. Once you make a tuple, you can't change it. That's why this is allowed. Finally, I'll run our last case. In our last case, what happens is, oh, sorry. So you can see that unhashable type list. So this is basically their way of saying don't put a list as a key because list can be changed. So this is the idea. Okay. So I hope this is clear to everyone. I think you guys were confused between A and B, but there is nothing wrong with having a nested dictionary. The value of a dictionary can itself be another dictionary. That is perfectly fine. You can have strings to be keys. You can have other things. But the main point is that you can't have list. List can be changed. Okay, this is the idea. Okay, so now let's try to go to the programming part. I have 4 programs for you today. Let's try to do at least 3. We have 45 minutes left. So, okay, so as usual, I will give you some time to work out the program and then we can discuss the solution together. Okay, and please, all of you sincerely try the program. As I've said over and over again, this is the only way you learn programming is if you try to write your own programs. Okay, so here is the first program statement, problem statement. You have to write a Python function frequency of n, which takes input as a list of integers and returns a pair of the form min frequency list, max frequency list. And these are two lists. These are two lists again. Min frequency list is a list of the numbers with the minimum frequency in n, sorted in ascending order. Max frequency is a list of the numbers with the maximum frequency in n, sorted in ascending order. So if that is confusing, here are some options of how to, okay, give me a second. Here are some options of how it works. Yeah. So for example, in this list, I'm giving frequency of this whole thing, right? 13, 12, blah, 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 blah. So frequency, by frequency, I mean how many times it occurs. So in this list, for example, 7 occurs only once, right? So that is the minimum frequency value. So it gives a list with 7. In the what is the number that occurs the most number of times? You can see that 13 comes 1, 2, 3, 4 times. So 13 is the max frequency. But sometimes you might have some list where there are more than one number which is occurring more than once, right? Sorry, yeah, as in more than one number which is occurring a maximum number of times or minimum number of times. In that case, you have to return all the numbers that are occurring in a list, in an ascending list. So for example, here you can see that this list has 13 occurring 1, 2, 3, 4 times. 14 is also coming 1, 2, 3, 4 times. So you have 13, 14 to be the maximum number, and 7 is happening only once, so that's why 7. In this case, you can see that 7, 11, and 12 are all occurring the same number of times, just twice. So that's why they are part of the minimum frequency list, and this is in the maximum frequency list. So does everyone understand the question, first of all? Do you all understand the question? Yes, no, maybe? Should I explain
Can
again?
can you oversimplify it and don't get the actual problem?
Okay. I'll explain the problem again. Basically, you have a list, okay? List of numbers. In every number is occurring certain number of times, right? So, for example, take this first list. Uh, there is 13 is occurring 4 times. 12 is there 2 times. 11 is there 2 times. 14 is there 2 times. 7 is there once. Correct? Now, I want to take number which is occurring the least number of times and the numbers which are occurring the most number of times and make separate lists. So in the first example, the number which is occurring the least number of times is 7 because it is there only once in my list. So 7 becomes my min frequency list, right? Similarly, the number which is occurring the most number of times is 13 because it comes 4 times in my list. So that's why it becomes my max frequency list. Okay. Now, in certain cases, you may have that multiple numbers are happening the minimum number of times and maximum multiple numbers are occurring maximum number of times. In that case, you have to print all of those numbers and you have to print it in ascending order. So you can see here that 13 and 14 are occurring 4 times. That's why I print 13 comma 14. In the other case, you have 7 occurring only once. That's why it's like this. The other case is like this. Okay, is this clear now?
Yes. Why different lists are getting generated? I don't get that point.
Because why
Hello?
I can't hear. Why is this getting generated? Because this is the problem statement. The
No,
problem
no,
statement
no,
is
no. No. Actually, look, I understood the statement, but different lists are getting generated. So, I mean, why is that?
because that is what you're asked to do. This is a place where I'm asking you to generate those lists. You please generate those lists and write a program for it. That's a problem statement. That's why.
Okay, okay, basically, we have to generate different lists. Okay, okay, I get it. Yeah. Thank you.
Got it? Okay. That is a function. Okay. So try writing the program. I'll give you a few minutes to kind of, if you can't write the full program also, it's fine. Just try to figure out the logic. Okay. But I would strongly suggest try writing the program. I'll give you 5 to 10 minutes and then we can discuss the program together. Okay. So try doing it yourself. I'll give you a few minutes. Are you guys trying? Hello.
Yes, yes.
Okay, okay, good. So, did any of you get the solution? Okay, okay, someone has written. So, my logic is make a list of unique items from the original list, count the unique items from the original list. Yeah, okay, cool. That makes sense. So, yeah, you can do that. That's fine. So maybe I'll give you a few more minutes in case some of you are trying, and then I can show the solution. So yeah, this is one way to do it. So when you say count the unique items from the original list, you mean okay. So first you're trying to identify just what are the numbers which are coming, and then you're counting each number how many it is coming with the unique with the original list. Right. Okay. And then you have to of course write the maximum and the minimum to separate list, but that I guess you can do in any way. Okay. Is there any issue with my internet? It shows poor network quality. Please let me know. I'm not in my institute, so just let me know if I drop out or something. Okay. Okay. Great. Sure. Okay. So maybe because it's already 7:24, I'll show the solution. Those of you are trying, you can continue to try. I'll show you the solution how I have done it, and we can try to do the other programs. So this is week 4, program 1. Okay. So yeah, so here basically, as you can see, basically we have three functions. One is to find minimum, one is to find maximum, and here is the frequency. This is basically how much counting. Okay. So as you can see, we defined count to be a dictionary. So here we are using something that we have discussed here, right? Which is dictionary. So similar to the idea your friend was telling about where we are making a unique list and then counting how many times each number comes. The similar thing is to have a dictionary with keys and where the values are actually what how many times the value is coming up, right? Because keys can be only unique, right? That we already discussed in the in the theory part, and also when we did the MCQs, we discussed that keys can only occur once. So in that sense, the keys of the dictionary will tell me what are the unique elements in the list. Okay, so I'm just using the fact that key tells me what it is. So here you can see that every time I see n which is coming in the keys, I am increasing the count by 1.
I
And
missed the half.
otherwise, sorry, hello.
Actually, I missed the half an hour class. That's why my logic was different from you. Now you're correct, ma'am.
Yeah, yeah, okay, great. No, no, your logic is not wrong. It's correct only. I'm just trying to do it in, as I said, programming is somewhere where we have full creativity, right? So we can always do it in different ways. So here we are using one new data structure which you guys learn, which is dictionaries. Correct. So here you can do it with different lists. Here we are doing it with keys. So you can see that every time n comes in the count, we add one. Otherwise, we start with one. So basically, you initialize it to one, and every time it comes after that, we keep on adding one. So minimum list just you can find from the minimum of count. Maximum list you can find from the maximum of count, and find min and find max are two other functions. So let's see what two other functions are doing. Here, find min it takes some number, and if d is greater than upper bound which we define to be 0 in the initial case, if it is greater than 0 then we define it to be the new case, and so on. So minimum list becomes this, minimum count is upper bound. So here why do we need a minimum list? Because there may be multiple numbers which are the minimum, right? Not just one number. So that's why for n in d of keys, so again we are checking the keys. If any of them are less than the minimum of the count, then yeah, we update to the list and the count accordingly. Else if it is equal, then we have to append it to the list. So if any of them are less than it, we have to update it. If it is equal, then we have to just append it and then sort it out. So this is a, we are using sorting, the built-in function for sorting a list, which is sorted. But by now you should have n number of ways, I mean 5 ways at least to sort a list, right? So you should be good in that front. So you can replace the sorted function with one of your sorted, which is one of your sorting functions itself as well, one of the pre-written sorting functions that you have, bubble or any of them, the ones we discussed today also, merge or quicksort. Similarly, for maximum, we keep the maximum count to be something, and then you can see that we have updated if any of the dictionary, I mean if any of the dictionary keys has higher than max count, we increase it. Otherwise we append it to the list, and then you return the sorted list. So this is the idea. So it's quite simple. The main thing here that we did, which was a slightly different step, is that we identified that dictionary can be a good way to store unique values and the count with them. That was the main difference that we had here. So let me just run the program. So let's enter the elements of the list. So let's say 1, and then 2, 2, 4, 2, 3, 3, 4, um, 5. Okay, so you can see that 1 and 5 happen only once, and 2 is there thrice. So 2 is the one with highest frequency, and 1 and 5 are the ones with lowest frequency. Now if I do this, you can see that output is 1 comma 5, which is the minimum frequency elements, and the 2, which is the maximum frequency element. Is this clear to everybody? Is this clear? Any doubts? Okay, great. Thank you. Thank you for replying. Yes, okay. So let's go to the next program. So here you can again see how dictionary helped out, right? So that's the point, that there are different data types, and of course you can do the entire program list also, but sometimes some data types are better equipped for certain programs than others. So it comes with practice that which data types are best for what. That's why we learn all these different things. Okay. So let's go to the next program. It's a little long, so let's try to read it carefully to understand what it is, and then we'll do the program. Okay. So it's a long program. So let's try to understand the question. So an airline has assigned each city that it serves a unique numeric code. So let's take it to be Chennai, Bangalore, Mumbai, Hyderabad, or something. So 1, 2, 3, 4. Okay. It collects information about all the direct flights it operates, represented as list of pairs of the form I, j, where I is the code of the starting city and j is the code of the destination. So suppose Chennai to Bangalore, Chennai is 1 and Bangalore is 2. Chennai to Bangalore will be represented as 1, 2. Okay. It now wants to compute all pairs of cities connected by one intermediate. Sorry, this is a typo. This should not be hope, it should be hop. Yeah, one intermediate hop. Okay. So suppose there is a flight like Chennai to Bangalore, Bangalore to Hyderabad. Then only one hop is there in between, right? You're going from, if I want to go from Chennai to Hyderabad, I pass through one city basically. So city I is connected to city J by one hop if there are direct flights of the form I, K and then K, J for some other city K. The airline is only interested in one hop flights between different cities. Pairs of the form I, I are not useful. So I don't want Chennai, Chennai, for example. That doesn't make sense. So you have to write a Python function, one hop, that takes as input a list of pairs representing direct flights as described above and returns a list of pairs for all pairs I comma j where I is not equal to j. So again, no Chennai comma Chennai, such that I and j are connected by one hop. Okay, it may be the case that there's already a direct flight from I to J. So long as there is an intermediate K with a flight from I to K and K to J, the list returned should include I comma J. The input list may be in any order. The pairs should be in a dictionary order. Each pair should be listed exactly once. So let me just explain the last part. Suppose in my flight, so again, Chennai, Bangalore, Hyderabad, Mumbai. Okay, so 1, 2, 3, 4. Okay, so suppose I have 1 comma 2, which means there's a flight from Chennai to Bangalore. Suppose I have 2 comma 3, which means there's a flight from Bangalore to Hyderabad. I also have 1 comma 3, which is Chennai to Hyderabad direct flight. So when I return it, I will still have 1 comma 3 because basically there is a route with direct flight, but there's also a route with hop, right? Where Chennai, Bangalore, Hyderabad is there. So that's the idea. So you have to check for all the lists, all the cases, all the pairs with just one connecting flight between them. So it should be like I comma K, K comma G. Okay. Even if there's I comma J direct flight, you should still return that. So let's look at some examples. This will make it easier. So for example, here 2 comma 3, 1 comma 2, you can see that clearly there is a flight that can go from 1 to 3 with one hop. So 1 to 2, 2 to 3. Here you can see that there are multiple flights. You can check if it's correct. Here you can see that there is no such one hop flight. 1 to 2, then you can't go anywhere else. 3 to 4, you can't go anywhere else. 5 to 6, you can't go anywhere else. This is the idea. Is there any questions? Any doubts or questions in this? This is a longish question, but the idea is simple. I have pairs of numbers which represent starting and ending cities for an airline, and I just need to identify one hop stops, uh, one hop flights, which are where the flight has a one stop between the two destinations, and this is represented as I comma K, K comma G. So this is the idea. Uh, you guys, I'll give you a few minutes and then we'll discuss. You just try to figure out the how to index it and how to do, because again, this is not that difficult to do in principle, but it's like the data types and you have to check certain things. Those are the things which are difficult here. So I'll give you some time to check that. Okay. Okay, I'll give you some time. I think there are no questions, doubts in the question itself. So just let me know about this. Okay. Okay. Are you guys trying? Okay, good, good. Okay, I keep trying. I'll give you 5 more minutes and then we can discuss the solution. Okay. Okay, those of you are trying, you can continue to try the solution. I'll just show the answer because then we can do the other problems also. Okay, so let me just share my solution, how I have done it. Okay. So here you can see that we have this one hop. Again, we are going to be using
Hello,
dictionaries.
excuse me.
So yeah, please
Hello.
go ahead. Yeah.
Yeah, before showing the program, can you just summarize the logic behind few minutes? Because developing the logic was the hard part.
Okay, sure. So we can look at the program and the logic together. Yeah, I'm just going to, I'll show you the program. Okay, cool. So here the idea was that we need I to K to J connection, right? So let's go to the program, right? So here you can see that so first of all, if length of L is less than 2, okay. So let's go in order. Otherwise, it will get confusing. So this is basically just to check where the pairs IJJK. Sorry, what is it? Yeah, IJJK. We are checking in this loop. The other one is to basically implement that loop and get the logic. Okay. So here you can see that. Hmm. So let's okay. So first of all, the list, if the list has less than two elements, then we are not going to be having this hopping business, right? So this is going to return L. Okay, if L of 0 is not equal to L of 1, then return this plus. Okay, so this is a recursive function. As you can see that I have defined the function, I'm calling the function within the function. Every time I'm basically reducing the number of options by 1. So if L of 0 is not equal to L of 1, basically means that in this list, if I don't consider the first element, then I return up to the first element and then I check for the other elements. That's what's happening here. Okay. So so here where is this function being called? Let me see. Yeah, okay, so I got it. So first of all, you have this one hop function. You have the direct flights. You're just identifying the direct flights. Okay, for I comma j in L, for any pair of elements in L, this is all the direct flights, right? I comma j are the direct flights. So I in direct of keys, I'm just saying, I'm just putting all of them in a thing. So this is the direct flights, I comma j. Then I'm having a list called hopping. So hopping is basically which is showing you with stops in between. Okay, so this is the direct flights. These are the hopping sort of flights. So now for source in direct flight and for destination also in direct. I mean, there will be some direct flight between the source and direct, right? So source in direct flight and destination in direct of source. So suppose direct has the keys 1, 2, 3, and the keys have the value 1 has a direct flight to 3 and 4, 2 has a direct flight to 3 and 4 and 5, 3 has a direct flight to 1 and 2, etc. So that is why this is direct of source. Then if destination is in direct of keys, that means that is the source. That okay. So I'm saying source and destination, but those are the value variables which are using here. So let me say starting and ending. So here first, I identify all the direct flights. Those are all the pairs. One, two, one has two, three, four. Two has three, four, five, something like that. Then I'm checking in the direct flights. First, I'm starting with the source. Source will be the keys, right? Keys will all go to some destination. Suppose one is going to two and three and four. Okay. Then I'm checking if the two itself has a direct flight, right? So two will be in direct of keys. Then that will give me the remote location. The remote location is basically uh, whatever is 2 going to. So 1 is going to 2, 3, and 4. 2 is going to 4, 5, and 6, say. So if source is not equal to remote, which means that I shouldn't get a circular flight. I shouldn't get 1 is going to 2, 2 is going to 1. Then that will give me 1 comma 1. That I should not get. So as long as source is not having that, then I get hopping to be source comma remote. Okay, so this gives me all the flights routes basically. First, I identify all the direct flights. This gives me all the connected routes. So this is for, maybe I'll write it here. So this is for identifying all direct flights And this is for identifying all possible routes with hops. Okay, so here I'm not again checking for the one hop situation. I'm not yet checked for that. I'm just checking. Suppose I have 1 to 5 as 1 to 2, 2 to 3, 3 to 5. That is also going to be picked up by this. Okay, that is the idea. So it identifies, suppose 1 comma 2, 2 comma yeah, it identifies all such hopping cases. Then this is the case where you actually get check for the other case, which is that you're checking for what are the list, whatever you get in the list, you're trying to check which are the things. So like let's see how to think about how to explain this. 1 comma 5, suppose I have only one element in the thing. That means that yeah, I mean every hmm, okay, let's just try to understand by printing hopping. That will be the easiest way. So okay, good. So this will help. Now I'll just comment this. Okay. So here, not here. It's printing in the loop. Let me print it out the loop. Confusing. Okay. So this is, yeah, let me just, so print hopping. So it gives 2 comma 1, 2 comma 1, 1 comma 3, 1 comma 4, 1 comma 2, all of the possible possibilities, right? And then here what it actually does is that it checks for the oh, I'm sorry. Wait, I'm sorry. I'm sorry. I was wrong. This actually checks for the one hop case, right? I'm sorry. Roots with one hop. I'm sorry. Yeah, I've been traveling. I didn't look at this properly. Okay, so okay, let's see. Sorry guys, now I got it. Okay, so first of all we are checking if source is in the keys, which means we are the starting, we are fixing the starting source. Okay, now we know all the direct flights going from that source. The direct dictionary is just for all the direct flights, so we fix the starting location, we find what are the direct flights. Then from that destination, the middle hopping destination, we check for all the direct flights. So that already gives me the one hop thing, right? So this sorted thing is to just sort it in the I mean hopping. Basically they said that you have to print it in dictionary order or something, right? So I think that is it, because here you can see that 2 comma 1 is coming twice, 1 comma 3, 1 comma 4, 1 comma 2, 1 comma 2 is the same as 2. No, oh yeah, it's basically to sort it up. That's what's happening. It's not a big deal. Okay, so this is the idea. So this is where the actual one hop thing is happening. I'm sorry I was confused in between, but this is what is happening. This is why printing is good, by the way. I just figured it out by printing out what was hopping actually doing. So here basically we have done it in terms of a dictionary. We take all the direct flights, we take it like the key is the starting flight and the value is the destination flight. Then we check if the destination flight itself is a key. That tells you about the starting flight, right? So that's the idea. Give me one give me 1 second. My computer is low on charge. I'll just plug in my charger. Okay, give me just 1 second. Okay, do you guys understand the program? I'm sorry, I got a bit confused in between. I've been traveling all day, so I've a little bit, maybe didn't, yeah. check it properly. But yeah, is this fine for everybody? We're just trying to make a dictionary of the direct flights and then connecting key to value, then that value to the key, then key to another value. So that's how you get the one hop situation here. Yes. All possible routes in the sense that all possible routes with one hop, and then checking the frequency and printing it in a dictionary order. Yes. Okay, good. So it's 7:48. Let's try to do one more program. I think we have time. And then the other program, all the programs are being shared with you. So if you have any doubts, you can do it. Like, let's go to the next program. I don't think there's any doubts. There's only four of you. Any doubts here in this program? It's a little confusing, but basically, yeah, we made a dictionary of direct flights. Then it's like direct flight in the dictionary, the keys represent the source, the values represent the destination. So we are going like key to value, then that same value to another key, then that key to a value. That's what we're doing. Okay. That is the basic logic of the program, since someone was asking. Okay, great. Let's go to the next program. And then we have 10 minutes. So let's try to do one more program and end the class. Okay, and this is a slightly simpler program, I think. Oh no, I mean, it's not as long. That's what I mean. So write a function insert, okay, that accepts a sorted list of integers. So, you know how to sort a list of integers, but here you can actually provide a sorted list of integers and an integer x as input. The function should return a sorted list with the element x inserted at the right place in the input list. The original list should not be disturbed in the process. Okay, so you have to generate a new list which has x also included. You can't use any other, don't use just sorted of list. That is not allowed here, even though we use it in the last two programs. Don't use sorted of list. Do it brute force. Do it by using loops and other things. Okay. So, yeah, basically the only built-in methods you're allowed to use are append and remove. So I'll give you we have 10 minutes. Try doing this program and let's close by discussing this program. Okay. Oh, sorry. This is the program. I was just trying to shift it. Yeah, don't, as in, I don't, by hard coding in the sense that, see, one very simple way to do this is append X to the list and then return sorted of list, right? Don't do that. Don't use sorted of list. You do it by hard coding. I don't want you to do it in two lines. I want you to actually do it with a for loop or whatever is required. Is that fine? Okay, good. See, I'll give you a couple of minutes and then we can discuss the answer. Okay, I think let's discuss the solution because time is running so short. I hope some of you have been trying. Those of you are trying, if you've got the solution, that's great. Others keep on trying. I am going to share my screen with the solution now. Program 3. Okay. Okay. So, right. So here you can see that I'm entering a list and I am entering X, and the idea is I want to insert that element X into the list at the correct position. Okay, so I'm having a sorted list first of all. That's very important. List is already sorted. I'm trying to enter X element into the sorted list. So here you can see that I have a function which takes L and X, and because the function, I mean the program told me not to problem statement told me not to change L. That's why I have another list called out L. Okay. Now I'm going to have a flag which is inserted. Okay. And I'm going to keep inserted as false. Now you can see that I have a commented part which is not inserted as true. This is another way to do the same thing. So whenever, if you want to use this kind of thing, you can just uncomment all these lines. Okay. These fifth line, ninth line, and 16th line. Anyway, so we first of all keep inserted to be false. Now for elements in L, if not inserted, which means not inserted means if inserted is false, right? Not inserted is true because inserted is false. The moment inserted becomes true, this becomes false. Okay, just think not always reverses the
Well,
true or false condition.
excuse me.
Yeah.
Why we use this inserted? I didn't get that.
Okay, okay. So this is a flag.
And
This is just the flag.
why we put it to the false?
Yeah, so you'll understand when I explain the program. This is a flag. A flag means it's basically a value which indicates whether the X has been inserted or not in the list yet. Okay, so the moment that I append X to my list, I turn it to true. Okay, that is the idea. So for each element in L, I first check if X has not been inserted and the element is greater than X, then I keep appending it. Okay. So inserted becomes true the moment I append X to the list. Okay. Otherwise, I append elements to the list. That's the idea. Okay. This in not inserted case is when X is bigger than all the elements. Okay. So I keep doing this until I find an element which is greater than X. Because this is a sorted list, the moment I find an element which is bigger than X, the very first element which is bigger than X, just before that I have to append, right? This is already a sorted list. Suppose it's 1, 2, 4, 5, correct? And I want to insert 3. I will check first 1 is greater than X, no. 2 is greater than X, no. 4 is greater than X, yes. So I immediately insert X between 2 and 4 because it's already sorted. And then I turn inserted to true so that can indicate to the program that X has already been inserted to the list. You don't have to check anymore. So I don't insert 3 twice or something into the list. That's why this flag exists. This flag is for indicating that X has already been inserted into the list. Okay. Now it can also be that I have a list like 1, 2, 3, 4, and then I'm trying to insert 5. So 5 has to be inserted at the end of the list. So this whole elements will get over, and inserted flag will not be true because it has not been inserted anywhere. If at the end of this whole process inserted is still false, then I append it at the end of the list. Is this understood to everybody? Is this clear to everyone? So again, there are two things. One is I'm going through the list. The moment I find an element which is bigger than X, I can insert it there. That is why, because I have a sorted list already. The other thing is that I want to insert the element only once. And I want to know when I have inserted it. That's why I have this flag which says false or true. Is this okay for everybody? Let's try running this program and we'll see what happens. So let's say 1, 2, 4, 5 and 3. So 1, 2, 3. Okay, I wrote it as 45 by mistake, but the program still stands, right? I get 1, 2, 3, and 45. So that's correct. So the flag is basically to make sure that X is inserted only once, and in case X is not inserted at all, that tells me that it should go at the end of the list. Okay. So here one important point is that the list should be already sorted. So, of course, you can do it with any ordinary list also, because as I said, you know how to do sorting now. You know how to do sorting with built in methods. You know how to do sorting in 5 different ways. So, it's very easy to build the complexity of this problem and just have an extra step, which is just sorting the list before you do this process. So remember, programming is all about connecting the things you already know, and trying to make a program your own by adding more and more elements is always easy. Okay. Any questions in this program? We are also at the end of the class. I don't think any doubts. Okay, if
No.
not, thanks for joining at this unusual time. My classes are usually Saturdays 3 to 5, but as I said, this week I am traveling, so I was not able to take the class at the usual time. That's why I preponed it. Thank you guys for joining nonetheless. All the sessions and recordings will be posted in the usual places, and please find them. If you have any doubts, you can mail me. I think we can end the class for today. Okay, thanks. Any final questions, comments?
No, thank you.
Okay, thanks. Have a happy weekend. Okay, bye, guys.